Hi, thanks for being here. So today I will talk about some very common problem in Rails ecosystem, which is something that I don't really experienced on my 9-year long career as a Rails developer, which is logic-free views. And I have tried to, when I prepared to the presentation for today, I tried to take the shoes of the speaker, imagine how I will feel on the stage. And I realized that how much of you actually use Rails on the daily basis? Yeah, so I realized that I will try to go to the 99.9% of Rails audience. I will try to not only say that you have problems, guys, but also be crazy enough to aim that I have some kind of solution. And yeah, so this image came to my mind already, like immediately, that I will be like a sheep among the wolves. But then I read that if you present yourself or introduce yourself as a sheep among the crowd of wolves, they will just eat you. So I asked the AI generator to give me another image. And I will present myself like this instead to gain some confidence. I'm Sebastian. I'm already introduced, so I will not repeat myself. Yeah, let's go into the topic. I will talk about Hanami today. But what is Hanami? Hanami is a Ruby framework, a Rails alternative, if you may say. Some cool facts about Hanami is that if you present the view layer in the diagram, it will appear as a Ruby shape. The architecture is so well thought. Ruby market is not very much in the whole web ecosystem. And like we all of here, right? We are kind of like a 2, maybe 3% of whole web applications market. And Rails has like 95% of Ruby market in terms of web. So Hanami, Rhoda, Sinatra, Bridgetown, and whatever else you may imagine is like around 5%. So pretty niche. Those are very small projects, but very important ones. Hanami is a framework that if you will choose to write about, I have a blog about, I will be your only competition. If that's not tempting, I don't know what is. But it is also an example of courage. It is easy to me to just start a blog about Hanami because I already know that there are projects, companies that earn millions of dollars per year and are backed in Hanami. They are careers built around it, even though this is so niche. So it's easier. But authors of Hanami, when they decided to go against the main stream of working the Rails way, and they decided to say publicly that they have something to do better or different, but still good, still well, that is pretty brave. So Hanami is a result of courage, I would say. And today I will talk about one particular issue, but we'll mention a few of them. Because Rails has issues. Rails is great. It proved to be great over years. It has still a very stable community. It has very impactful. It impacted like the whole web ecosystem. Like it brought tons of creativity, sparks, and then explosions across all different kind of languages. So there is no doubt that Rails is great, but it still has some issues, and some of them are very Rails specific, to the extent that before Rails, I almost didn't hear about them. And N+1 queries is one example. It's an example of, I heard about it at the university, but nobody spent too much time on this because nobody thought that this is like important enough. But in Rise ecosystem, this is actually an issue. We get like a whole ton of projects that aim to resolve that or help resolving that, debugging and so on. And we still didn't like manage to just escape of it. Tools like AppSignal have the dedicated parts in the UI to just monitor about N+1 queries. And this is really not very complex issue from the database design or query build design. Rise has some problems in terms of lack of abstractions. There is the MVC pattern, and there are helpers, and not much more. Obviously, as a community, we developed more sophisticated approaches and invented some additional building blocks like service objects that we had today, or the view objects, form objects, decorators, there is like absolutely a ton of it. But nothing is like backed by Rise philosophy. In Rise, there is like a MVC, and this is like very, very old picture that I spent a lot of time to actually find, because this is something I saw like dozen year back for the first time. And in general, there is a philosophy that there is like a skinny controller, skinny views, and the rest remains in models. So obviously, there are endless discussions around the architecture. Rise is also all or nothing. We waited multiple years to get to the point where the Rise core team decided to allow us to build API-only applications where you can disable some key components, like disable view layer or disable the persistence. But you still need to install it. You still need to have it. And because of the monkey patches of the Ruby system, Ruby language itself, it's really hard to replace the whole active record with something else, or don't use active support, or use the custom router, for example. I'm not sure if that is even possible. And in Hanami, this is a little bit different. The whole philosophy is that to allow you complete flexibility, more like a RODA. When you have the plugin system, you can install each functionality separately. And in Hanami, this is the similar approach, where you can just completely disable the router controller. If you don't need validations, or you don't need persistence, you don't need views, you just get rid of them completely and don't even include that in the gem file. And because of that, because of Hanami is so modular, I came up with this topic to the Rise community. Because Hanami came with an interesting approach to solve the view layer. And recently, the 2.1 release had been published, and it is officially done. So we now have the Hanami View module, gem, that can be used, that is framework agnostic and can be used in any Ruby application, really. And I will show it to you as an inspiration. I don't expect that you will all just replace your default templates and start implementing Hanami views, but some of them can be taken as an inspiration to improve your existing projects. Okay. Oh, this is the difference. I wish I would know that before I ended all my funny section. So, logicless views. I have here the form, the simple registration form. And nothing fancy, a few text fields, one checkbox, two buttons, few icons, some placeholders, and that's it. But still, if you check the HTML, it will be pretty blown up to make it looking good. And yeah, those are the text fields, and here are the checkbox and the buttons. And when you click, there is like a validation presentation logic here, where you highlight the input fields, you present the control field errors, like field specific errors, and show some information at the top. So this simple form actually hides a lot of logic. And I will show you that even though you know that, not everything is obvious. And Hanami came up with this layer, this concept of not only have templates on your view layers, but also provide additional tooling, like optional tooling, to extract some additional logic to Ruby, like encapsulate the parts of the logic in the Ruby objects that are easily testable, and that can be that can keep your views very clean. So yeah, I will go through it very quickly. So there is actions. Actions just go to calls the views, and the view is an object, a Ruby object that decides what is available in the template. Like nothing really is available until the view decides to do it, to enable that. If this variable that is going to be available in the template to be rendered needs some decoration, then it's decorated via the parts class. You can name it decorators if you wish. And then if there are multiple partials to be rendered and they need some calculations of the locals, there are also another Ruby objects that allow you to calculate this logic, and those are scopes. Helpers are, just helpers. So first, let's go with the rendering field errors. I will go with creating a view. This will expose to my template a form object. And usually, as you can see, it would be just a hash. A hash that will have values keys and the errors keys. But to make it more pretty, I will decorate this hash. Without this decoration, in the template, I would just have like a hash under the form variable. But I will decorate that using the registration form part. And in the registration form part, I will have an error method. So instead of just treating the form as a hash, I will have an errors method that accepts the form input name, and that will fetch the errors to my template. The good thing is that you will not have a nil here. You will always have an array, empty array or whatever, because this logic is extracted and it's easy to do so in Ruby object. So now our form field would look like this. So if at the top, if there are errors, I can use the form variable that I exposed, and I can use the errors method that accepts the username as an input. It will fetch from the parameters the errors for the particular field. And then I can just render those fields, also passing the errors into the partial. The error partial would be quite simple. It will just have some exclamation icon and some messages in the loop. So you can see here that messages, we don't need to have any additional to to array transformation, because we have guaranteed that the messages are array already. So that solves the error presentation logic. Now let's go to the form input logic extraction, because showing errors is only one thing, but there's a lot of more logic hidden in a single field. I will work now with a single field only. I will extract the text field as a separate partial, and from now on I will try to make it unified. So the goal is to have a partial that can be applicable for multiple use cases, and like all three fields in my form were pretty much the same. They just need some identification to be passed in as a local. So assuming that, like having the field name and the label text, this is like only thing that is really required. And then the rest can be calculated. But so let's find all the dynamic variables here, anything that behaves differently and that can be extracted out. And definitely the field name and the label text are the first things that come to my mind. But there is also this icon here, the icon span. And this icon, the FA user icon, this is exactly the same as what we had just before in the errors field. The only difference is that the name and the alignment of this is different. So we can easily extract that to a partial as well. It will be something like this. But then you can see that the control class, the div class that wraps around my field does not have the has icons right CSS class. And this will break the rendering of the errors icon. So we have just discovered a bug. We need one more dynamic thing, and this is the control class names that can include has icons right in case of the error field. And then when I go further, I can get rid of the field specific name when I pass errors to the partial, to the error partial, by also extracting this as a part of dynamic logic. And I can just pass the errors variable instead to the errors. So we are going somewhere. There are a few things only to left, and this is the next step, which is whenever the partial has, whenever the form field has an icon, then I have the has icon right CSS class. If there is no icon, if there is icon empty, I don't want that class. So I will also include that in the dynamic control class names and have something like a has icon condition, which will check if the icon name is nil or not. Finally, I can add some placeholder and some input field classes, which is adding the danger, like styling, some more styling in case the error appears. And that's it. Like this is all that is extracted out from just a single form field that you want to reuse in your forms. Pretty lot, but you most likely don't want to calculate any of this inside of your templates. And you don't want to pass all those variables as locals to your partials. So this is where we can use scopes in Hanami. Scopes will allow you to render a form input field partial passing only minimal set of locals. And scope is an object in Hanami that will do the calculation of the locals and figure out how to render the partial. So this is how it would implement, how it would look. This is a Ruby class. Not much is happening here. It really gets, like, I have only extracted those variable calculations as methods to just control the logic better, find out the bugs, and unit test the whole thing. Now, this would be the usage. Within my partial, I would need to use the scope method, define which class of the scope I would like to use. It would be like the input scope. And then pass the username, the field name, errors, placeholder, and label. Then I call the render on this, like which partial should be rendered with those locals as an input. And my scope will take this text field partial and pass in all the locals it needs. So, but it doesn't look very nice, really. So what could we do to really benefit from the scopes? We could use parts. We could use the decoration to hide the rendering logic even more. Like all those variables can be also figured out just by hard coding something. So like defining the username definition, decoration. Oh, sorry, I got lost. So if I have a registration form, I can define a few methods, like a separate method for the username input, the password input, or the checkbox input, the terms of condition input, and just pass the form builder to the method. I can also in this first form, I assume that my username scope method will return the scope instance, and then I would still need to call render with the passing which partial should be rendered. But I can even hide that in the decoration if needed. So now, as a final step, I will set up the part to decorate this final piece of logic. In my registration form part, this decoration that I have mentioned, I will just define which scope class should be used, and then define few methods. Like the username input will use the prepare scope with the username, and the password input would prepare scope with the password field. And all that will render the same partial. Then my form view, my registration view, gets to this form when I only call the decoration logic, the username input, password confirmation input, and TAC input. And that's it. The form still works the same. Oh. Depending on the fact if you want to keep the information of which particular partial is rendered, you can go with the first or second approach to work with those inputs, depending on how much respect you have to front-end developers and want to either make their life easier or a little bit harder. But that's it. This is all the logic that I have found that could be extracted. And while we are familiar with the view objects in Rails ecosystem even now, and while we have the need for decorating some objects, some values to have presented in the logic, the concept of having a separate Ruby class to take care of calculation of locals is pretty new. And before I jumped into the Hanami, I didn't realize that I needed that. So it proved to be useful already a few times in my daily work. So, but the cool thing is that all of that is optional. Like you can work with templates directly, you can work with the views, you can have some decoration in parts, and you can have scopes if your partials gets too complicated. And this is it. The conclusion is that working with templates is pretty hard, and that was never easy. But Hanami enriches you with the complete tooling, and I think this is the most complete tooling available on the web right now. There are pretty good solutions out there, like view components or Flex even, that are pretty cool and are pretty innovative. And all of those projects try to bite the view logic extraction problem from different perspectives. And I wish if in Rails ecosystem, we would pay more attention to those different approaches and get inspired to optimize our code bases. Like, don't be scared to use non-Rails way in the Rails applications. Thanks. Any questions?
Any questions? Anyone? I really like the part where you grilled Rails. That was nice. All right. If no questions, then once again, thank you, Sebastian Wilgosz.